In this video we're going to look at the quantification parameters regions property page and how quantification regions are defined in CasaXPS. A region is defined when we press the create button, and the result of creating a region is a set of parameters are established, and these are all just default values and now need to be updated with values that are appropriate for these data. And the first thing we should do is indicate the peak that we would like to quantify. So I've entered copper 2p, and I happen to know that these are copper 2p doublet peaks. So what I've done is I used the mouse to adjust the start and the end limits, and these represent parameters here and here. So I've now focused on the copper 2p using the region limits, and in order to update this region so I have information appropriate for this interval, I need to press hash and then return. And because the name is copper 2p, then the element library is searched and the relative sensitivity factor is updated. So this RSF corresponds to the copper 2p doublet, which includes both of these peaks. The next field to consider is the background type, and this is currently set as a U3 Tougaard background, and this makes use of these cross-section fields here. So the values that are defined here determine the shape of the background, and the first parameter is determined from the data itself, so it scales in order to force the background to meet the data at the start of the interval. So the Tougaard background is an example of how the photo emission signal is partitioned into a signal that can be assigned to photoelectrons, that's to say electrons that are ejected as a consequence of the photon, and inelastic scattering of electrons, and that is the function of the background is to remove a contribution that corresponds to the inelastic scattered electrons so that we can quantify the signal above this background using the relative sensitivity factor and other corrections that we need to apply in order to produce a quantification. There are other parameters. The average width, this relates to the start and the end position here where the background meets the data, and the value, if set to 0, then the background matches the data bin exactly, whereas if this value is greater than 0, I'm going to enter 3 here. This indicates that 3 data bins outside of the region and 3 inside of the region plus the data bin itself will be averaged to calculate how the background should meet the data. So this is intended to smooth out the influence of noise on the definition of a background. We also have a start and an end offset, and these two values are specified as a percentage of the intensity of the background at the two limits. So if I made this 10 for the start offset, then the background is reduced in intensity relative to the data by 10% of the signal. And similarly I could do this 20%, or let's say 40%. So these are intended to allow for shapes that might appear in the data at the region limits that would compromise the calculation of the background. So in this case we don't need offsets to the background at the start and the end, so I'll set these back to 0. And finally there is a tag field, and the tag field is a string, and this can modify how different pieces of information are extracted from a region when combined in a quantification report. But for the most part this is an alternative to the name field and is used also for annotation. Following these parameters, the outputs are displayed here, and they represent the area that's calculated for the peak above background. There's a standard deviation, and if we press the calculate error bars, then the uncertainty in the peak area is calculated using a Monte Carlo simulation. The full width half maximum for the peaks are then calculated and reported. So the full width half maximum corresponds to the maximum height, and then half that intensity, the width of the peak at half that intensity gives us the full width half maximum, and in this case it's approximately 2 eV. The position of the peak is another parameter that is reported, and this corresponds to where the vertical line appears when the region's property page is topmost, and this is calculated based on the data bins unless you tick this box here which says calculate maximum, and the maximum intensity is then calculated using a quadratic fitted to these data, so you tend to find more precision when you have noise in the data that might influence the position of the peak if you tick the box here. Otherwise then you will obtain precisely the peak position at one of the data bins. There's also an atomic concentration calculation that's performed, and this requires more than one region, and because we have a single region here it's 100%, but if there were more regions involved on this survey spectrum then the quantification that is calculated as regions are added will appear here. And then we have the maximum height and the minimum height with respect to this interval, and that's if the relative sensitivity factors are with respect to height rather than area, but the Schofield cross sections are based on the peak area in counts per second EV, so we would not expect the peak to peak concentration based on this RSF and other RSFs for different peaks to make any sense in terms of a height. So finally, after a region such as this has been created, the next thing that you would do is to add further regions, and then once the regions are defined, start to assess whether the intensity calibration in terms of transmission function, escape depth, angular distribution are all correct for these particular data.